Today's lesson is about volume of composite figures. We've talked about volume of different three-dimensional solids. So today we're going to combine a few of the figures, the solids, into a shape and then find the volume of that composite figure. So when I say composite figure, I mean two or more shapes that are put together to form one composite figure, composite shape. So let's just review our volume formulas real quick. So we have the volume, the volume of a cylinder, and again, all volume is going to start with capital BH. Capital B means the base area times the height of the prism, or the cylinder. So the base shape of a cylinder is a circle. So the area of a circle is pi r squared times height. So that's going to be the cylinder. Deriving the formula from capital BH is important. A cone is 1/3 of a cylinder. A cone is 1/3 of a cylinder, assuming they have the same height. You could take 3 cones and fill it up with water and pour it into a cylinder. So the volume is 1/3 pi r squared h. And the pi r squared comes from the base. Even though it's a cone and only has one base, the base is still a circle. A sphere has kind of a weird, because it doesn't really have a base, but it's 4/3 pi r cubed for the for the volume of a sphere. And so we've studied these 3 in class. And then just a review of the rectangular prism. If you were to start with capital BH for a rectangular prism, and the base shape of a rectangular prism is a rectangle. And so the area of a rectangle is length times width, and then you would bring down your h. And so the volume of a rectangular prism is length times width times height. But that should kind of be an old concept. And then don't forget that volume is in cubic units, cubic centimeters, cubic inches, inches cubed, feet cubed, and that's because we're actually taking cubes and we're fitting them in these solids to figure out how many cubes can fit inside of these shapes. So that's a quick volume review of all of our formulas. And I think we have 5 problems to do. Now, my drawings are not going to look maybe as good as the shapes on your picture. But number 1, look at number 1. It has a cylinder on top of what looks like a cube because all 3 sides are the same. So we have to find, to do a composite figure of volume, or to do volume of a composite figure, you find the volume of each shape and then you would add them together. Nothing, no secret shortcut, nothing spectacular. So we'll take the cylinder and we'll find the volume of the cylinder. I'm starting with capital BH. And I know the base area is a circle, so that's where I get my pi r squared from. And for these purposes, I think I'm just going to use pi. And then the radius. So here's one of the questions. In the cylinder, we need to find the radius. Well, it doesn't give it to you, but if you know how wide this is, and the cylinder sits directly on top of this cube, so if the cube is 12 inches, then we know that the diameter is 12 inches. And if you know the diameter is 12, then we know that the radius is 6. So again, I got that because I knew that the cylinder was the same length across as the rectangle at the bottom, or the cube at the bottom. So the radius was the diameter is 12 and the radius is 6. So I can type in 6 squared. And then the height of the cylinder is 18. So I'm just going to use pi. Pi. And I get 2035.8. So I'm just kind of rounding to the nearest tenth. Sometimes I might round to the nearest hundredth. So that's the volume of a cylinder. Now the volume of a cone is length times width times height because it's a rectangular prism. And in this case, since they're all 12, you could just do 12 to the 3rd power. And the volume of the cube is 1,728. And your last step is you're going to add these 2 together. So you're going to add the cylinder plus the box, the cube, and your total volume is 3,763.8 inches cubed, cubic inches. So that's how you would do a total. You would do the part and add them together. Okay? So let's do some more examples. Example 2 is a cone on top of a sphere, except this is not the entire sphere. This is just a half sphere, a hemisphere. Now, we didn't quite go over hemispheres, but what you would do is you would find the volume of the sphere, and then you would divide it by 2 and take half of it. So first we'll do the cone, which is 1/3 pi r squared times h. And I just know that because I just wrote it down. 1/3 pi, and the radius is right here, 4. And the height of the cone is 10. I've already typed this in, so I'm not going to waste time punching my calculator. And I've got 167.6 centimeters cubed would be my volume of the cone. Now my volume of the sphere, again, I'm going to take the volume of the whole sphere, and at the end I'm going to divide it by 2 to get half of it. 4/3 pi r cubed. And the radius of the sphere is also going to be the radius of the cone because they line up on top of each other. And 4 cubed. The volume of the sphere is 268.1. But remember, I need to divide it by 2. And if you think you're going to forget why, then make a note on there on your notes that you divide it by 2 because you only need half of the sphere. But once you divide it by 2, we get 134.05. And then my total volume, I'm going to add these numbers up. My total volume is 301.65 centimeters cubed. 301.65 centimeters cubed. And the reason I rounded to the nearest hundredth here is because I had to divide this by 2. And if I would have rounded this up and said 134.1, it would have just kind of looked strange because it wouldn't have been half the sphere. So I just went ahead and rounded to the nearest hundredth. All right, number 3. Number 3, we have a cone on top of a cylinder. We have a cone on top of a cylinder. So we'll start with the cone. And I just wrote it. So I know it's 1/3 pi r squared times h. 1/3 pi. Now the radius of the cone, we have it right here, is 5. And the height of the cone would be the straight line up and down. 13 is the slanted, so we would need to go straight up and down. So you have a couple of options. You can use the Pythagorean theorem and do a squared plus b squared equals c squared, but I know that this is a Pythagorean triple, 5 and 13, so that means this has to be 12. If you don't know that, then you can do the Pythagorean theorem to find the missing height. So this would be times 12. I would type all that in, and the volume of my cone is 314.16 centimeters cubed. Now I'm going to do the cylinder. So the cylinder is the same as the cone except without the 1/3. The cylinder is going to start with pi r squared h. So the cylinder and the cone have very similar formulas. The cone is 1/3 of a cylinder, or you could say the cylinder is 3 times the size of a cone. Their radius is the same, so I'm going to use 5 again. But the height of the cylinder, this cylinder is just a short little cylinder, so the height is 2. The volume of my cylinder is 157.08 centimeters cubed. And then, like we've been doing, I add them together to find the total volume. Total volume is, 471.24 centimeters cubed. So you found the volume of the cone and the volume of the cylinder, and then you add them together to find the total volume. All right, example number 4. I like this one. I don't know, my drawing is not great, but for some reason I like the shape. Here we have a rectangular prism on the bottom and then a half a sphere on top. Kind of looks like a dome. So let's talk about the sphere, the half sphere. I just always start with the top. It just makes the most sense to me. The sphere volume is 4/3 pi r cubed. And again, I don't know it yet, but I can derive the radius because the diameter of the sphere is going to go all the way across the rectangular prism. So the diameter is going to have a value of 10 because it goes the length or the width of the rectangular prism, which means the radius is 5. And now I can plug it in. And when I do that, I get 261.8 centimeters cubed. But don't forget, that's for the whole sphere. So I need to divide it by 2. Oh, wait, no. I think that's my answer. I already divided by 2. Let me double check. 4/3 times pi times 5 to the 3rd power, which is 125. Oh, this is 523.6. Then you divide this by 2, and I had already divided by 2 to get 261.8. So again, you have to find the volume of the whole sphere and then divide it by 2 to find the volume of the rectangular prism. Now, the volume of the rectangular prism is length times width times height. So 10 times 14 times 10. And the volume of this is 1,400 centimeters cubed. You add both of these up. So we're going to add the volumes up. And my total volume, 1,661.8 centimeters cubed. All right. So that is the composite figures volume, 1,661.8 centimeters cubed. All right, one more. All right, so this last one, you try it. Pause it, you try it. You have a rectangular prism on the bottom and a half cylinder. Be careful, it's a half cylinder on top. So you'd find the volume of the whole cylinder and then take half of it. So pause it, you try, and then press play. So the half cylinder, pi r squared h, and the radius, so we know the diameter is 9, so the radius is 4.5. And then the height of the cylinder is this, how long the cylinder goes. So the height of the cylinder would be 42. And I'm going to take all this, and I'm just going to divide it by 2 because I only want half of it. And so my volume I got was 1,335.96 something. So I'm going to round to 1,336. It must round up, which makes that round up. But 1,336. Now that's the cylinder. The rectangular prism on the bottom is length times width times height. And when I put all those numbers in, my volume is 13,230. That seems kind of high. Just let me double check. 9 times 42 times 35. Okay. And then the last step is I add them both together to get my total. Total volume is about, because we rounded, 14,565 centimeters cubed. Now, maybe you didn't round. Maybe you rounded to nearest 10th or you rounded to nearest 100th. But if you were able to see that this is half the cylinder, that was the key, that you do half the cylinder and the rectangular prism. All right, we'll practice more in class.